Hi everyone, my name is Cy Venom and I'm a developer advocate with IBM. Today I'm back with another video where I'm going to be talking about all things Kubernetes. Kubernetes is an orchestration tool allowing you to run and manage your container-based workloads. Today I want to take a high-level look at a reference architecture of managed Kubernetes services and dive a little bit deeper about how you would do a deployment of your microservices. Let's get started here. So we've got here sketched out kind of two sides of the puzzle here. On the left side here, we've got the cloud side. And what we've got here is a very important component. It's going to be the Kubernetes master. The Kubernetes master has a lot of important components in it. But the most important piece that we want to talk about today is going to be the API server. The Kubernetes API server running on the master is integral to running all of your workloads and exposes a set of capabilities allowing us to define exactly how we want to run our workloads. On the right side here, on the customer managed side, we've got our worker nodes, which are all also Kubernetes based. There's one major component that I want to point out running on every single Kubernetes worker node, and that's going to be the kubelet. The kubelet essentially is responsible for scheduling and making sure our apps are healthy and running within our worker nodes. So you can imagine that the master and the kubelet are going to be working together quite often. Let's take a step back. Why would someone want to start using Kubernetes? Well, maybe they have some microservices, make up a cloud-native application. As we all know, microservices are talking to each other over the network. To really simplify this example, let's say we've got a front end and a back end. And those are the two components that we want to scale out and deploy to the cluster today. So Kubernetes uses YAML to kind of define the resources that are sent to the API server, which end up creating the actual application. So let's get started with that by sketching out what a simple YAML for deploying a pod, a really small logical unit allowing you to run a simple container in a worker node. So we'll start with that. We'll say we've got a pod. And what we need with that is an image that's associated with it. Let's say that it's a container. We've already pushed it up to Docker Hub, and we'll use my registry for this one. And very simply, let's say the name of the application is just F for front end, version 1. And one more thing that we want to add here, let's just say we've got labels. So labels are very important, and we'll talk about why in a second here, but allow us to define exactly what the type of artifact we've got here is. So for the labels, we'll just say the app is F for front end. All right, so we've got that created, and what we want to do is push it through our process to get it into a worker node. What we've got here is kubectl, kubectl. I've heard different ways of pronouncing that. But using that, we're going to be able to deploy the simple manifest that we've got and have it in one of our worker nodes. So we'll push the manifest through kubectl. It hits the API running on the Kubernetes master. That, in turn, is going to go and talk to one of the kubelets because we just want to deploy one of these pods and start it up. So taking a look, let's say that it starts it up in our first worker node here, with the label that we've given it, app is front end. And one thing to note here, it actually does get an IP address as well. So let's say we get an internal IP address that ends in a .1. So at this point, I could SSH into any of the worker nodes and use that IP address to hit that application. So that's great for deploying a simple application. Let's take it a step further. Kubernetes has an abstraction called deployments, allowing us to do something and create something called a desired state. So we can define the number of replicas we want for that pod, and if something were to happen to that pod and it dies, it would create a new one for us. So we've got that pod labeled as app is front end, and we want to say that we wanted to create maybe 3 replicas of that. So going back to our manifest here, one thing we need to do is tell Kubernetes that we don't want a pod, we want a template for a pod, right? So we'll scratch that out, and we'll create say that this is a template for a pod. On top of that, we've got a few other things that we want, right? So the number of replicas, let's say we want 3. we've got a selector, right? So we want to tell this deployment to manage any application deployed with that kind of name here. So we'll say match that selector here. Again, this is not entirely valid YAML, just want to give you an idea of the kind of artifacts that Kubernetes is looking for. And the last thing that we've got here is what kind of artifact is this? And this is going to be a deployment. All right, so we've sketched out that pod and we've got a new manifest here. What it's going to do, we're going to push it through kubectl. It hits the API server. Now it's not an ephemeral kind of object. Kubernetes needs to manage the desired state. So what it's going to do is it's going to manage that deployment for as long as we have that deployment and we don't delete it. It's going to manage that here. So we'll say that it creates a deployment. And since we've got 3 replicas, it's always going to ensure that we've got 3 running. So as soon as we got that deployment created, it realized, hey, something's wrong. We've only got 1. We need 2 more. So what it's going to do, it's going to schedule out deploying that application wherever it has resources. So we've got a lot of resources still. Most of these worker nodes are empty, so it decides to put 1 in each of the different nodes. So we've got the deployment created, and let's just say we do the same thing for our backend here. So we'll create another application deployment. Application is backend, and for this one, let's just scale it out 2 times. So we'll go here. Application is backend. And all right, everyone's happy. Now we need to start thinking about communication between these services, right? We talked about how every pod has an IP address, but we also mentioned some of these pods might die. Maybe you'll have to update them at some point. When a pod goes away and comes back, it actually has a different IP address. So if we want to access one of those pods from the backend or even external users, we need an IP address that we can rely on. And this is a problem that's been around for a while, and service registry and service discovery capabilities were created to solve exactly that. That comes built into Kubernetes. So what we're going to do now is create a service to actually create a more stable IP address so we can access our pods as a singular kind of app rather than individual different services. So to do that, we're going to take a step back here, and we're going to create a service definition around those 3 pods. To do that, we're going to need some more manifests YAML. So again, we'll go back here, create a new section in our file. This time we've got a kind service, and we're going to need a selector on that. And again, that's going to match the label that we've got here. And the last thing that we need here is a type. So how do we want to actually expose this? But we'll get to that in a second. By default, that type is going to be cluster IP, meaning our services can be accessed from inside the cluster. So deploying that through kubectl, hits our master, goes over here, and creates that abstraction we talked about. And we can say we created another one for the backend as well. So what we get now is a cluster IP. So let's just say CLIP for short. And that's going to be an internal IP. Say it ends in 5. And then another cluster IP for our other service here. And we'll say that it ends in a .6. So now we have a IP that we can use to reliably do communication between these services. In addition, the kubedns service, which is usually running by default, will make it even easier for these services to access each other. They can just use their names. So they could hit each other using the name frontend or backend or F or B for short. And so we've got that, and we've talked about how now these services can talk to each other, by using these cluster IPs. So communication within the cluster is kind of solved. How about when we want to start exposing our front end to our end users? To do that, what we'll need to do is define a type of this service. And what we want is a load balancer. There's actually other ways to expose, like node ports as well. But a load balancer, essentially what it's going to do, where this is internal to the actual Kubernetes worker nodes, we can create an external IP now. So say external. And this might be, let's say a 169 address. And now what we can do is actually expose that directly to end users so that they can access that front end by directly using that service. We've talked about three major components here today. We've got pods which are then deployed and managed by deployments, and then facilitating access to those pods created by those deployments using services. Those are the three major components working together with the Kubernetes master and all the worker nodes to allow you to really redefine your DevOps workflow for deploying your applications into a managed Kubernetes service. I know we talked about a lot today, but we want to get into more in-depth topics in our future lightboarding videos, maybe for example, something like deployments. So feel free to drop a comment below, leave us any feedback. Definitely subscribe and stay tuned for more lightboarding videos in the future. And thank you so much for joining me today.